We've covered what is inside our bones, let's zoom out and look at the functions of the bones in our skeleton. We can divide our skeleton into the axial bones, which follow along our central axis, and our appendicular bones, which make up our limbs. For this class, I do not need you to memorize all 206 bones of the adult skeleton. Instead, I want you to know what the bones do and locations of what I think are the key bones. You can see Canvas for a list of what I mean by key bones. So we start with our skull, which serves to protect our brain, and the only movable bone here is our mandible, or our jaw. We run down our back, we'll see our vertebral column, which protects our spine and helps keep us upright. We can divide it into segments: cervical for our neck, thoracic for our chest, lumbar for the base, think of those lumbar spine pillows, and then at the very bottom we have the sacrum and the coccyx, which is our tailbone. If the spine has a lateral curve to it, or a sideways deviation, this is a condition we call scoliosis. You probably had a spine check in middle school or high school where you had to bend down and touch your toes. What they were looking for was the start of scoliosis, which occurs during periods of rapid growth, like when you're in middle school. In our thoracic cage, we have our sternum in the middle, and that attaches to our ribs, which work together to protect our heart and our lungs. We also have our pectoral girdle, which is our clavicle, and our scapula, which is in the back. These help hold our arm. The clavicle in particular helps keep the arm braced away from our thorax, from our chest, and the scapula has the cavity that makes the socket for our ball and socket joint of your shoulder. The shoulder is loosely held, which gives your arm a lot of freedom for movement, but also means that there's a higher chance of dislocating it than our other ball and socket joint, our hip. In our arm, we have our humerus, and our forearm has a radius on the thumb side and the ulna on the pinky side. You can remember this with the mnemonic: radius is rad, thumbs up, radius. Your hand is made of 3 different types of bones. You have carpals in your wrist, metacarpals in your palm, and then the phalanges of your finger. Moving down our body, unlike the lightness of our pectoral girdle, our pelvic girdle, this is a dense and heavy bone area because it has to support all of our body weight in addition to protecting our reproductive organs. The female pelvis is more open and we say laterally flared or outward, and it's designed to create space for childbirth. The lateral flare also creates a larger Q angle with the femur, and this can lead to more knee pain in female runners. The coxal bone has a deep socket for our femur, which is the largest bone in the body. The femur is going to articulate or join with our tibia and the fibula in the lower leg, and there's a small sesamoid bone called the patella, which protects our knee joint and helps create more extension of the knee. Finally, we have our foot, which is structured pretty similarly to our hands, with tarsals in the ankle, metatarsals in the body of the foot, and phalanges of our toes. Now, we just quickly went through the bones of the body. Take some time now to draw out a skeleton and see if you can identify these key bones.